Hello, I'll be explaining the mechanical assembly of the robot. The four base components of the chassis are shown and attached in Lego form, which consist of motor housing in such a way that the motors can be attached rigidly. Next is due to inability of connecting the motors directly to the wheels, we had designed motor shaft extensions in such a way that the wheels can be connected. Next, the wheels are connected to the motors, and this is the complete wheel assembly. The next is the handles which are provided on either side of the robot for easy accessibility. And above each motor, there is a hole provided and there is a aero vent which is for to have continuous ventilation inside the base layer to avoid overheating of the motors. Next is the four top components of the chassis, and the skirts are provided on either side above the wheels for aesthetic looks. The camera is housed inside the chassis on one side. The middle layer is there above the base layer, which house other components. The top layer is provided on the top in such a way that the lidar is housed such that only the rotating component of it is there above the top layer and the rest of the lidar is inside. And this is the complete mechanical assembly. Next, I will be explaining the top layer. Due to problems of printing the entire top layer in a single way, we had to divide the top layer into different components. So top layer consists of three parts in top, a supporting layer at the bottom which is stuck, and a part which houses the lidar. And together, as you can see in the video, this is the complete assembly of the top layer.
Hello, I will be explaining object detection and tracking which we have used in the project Mars. ADA boost algorithm was used to train the object. The object we have chosen was a red color bottle. The algorithm is independent of the lighting conditions. On the left hand side, we can see the output from the camera. When the object is placed in front of the camera, a blue bounding box will appear, indicating the position of the object in the environment. On the right hand side, we can see the outputs are being printed. The outputs are the distance in centimeters and the angle with respect to the camera.
In the left of the screen, we can see the system screen, and on the right, we can see the real-time environment. There are three main components of navigation, namely SLAM for map generation, localization for localization of robot on the map, and path planning to generate a path to the final location. And as one can see on the screen, on the left, there is the robot, and this robot is provided with the initial estimate, and this initial estimate is then used to navigate the robot appropriately in the environment. And these red arrays represent the probabilities as to where robot can be. And then we provide a final goal. And on this final goal is then used to navigate the robot successfully while avoiding obstacles and localizing itself while doing the path planning to achieve the final location.